Hello everyone. Right now I'm working on, with this lab activity, it's going to be a side project that I'm working on, which is trying to extract and quantify and detect indole acetic acid in plants. And the way I'm going to do it is I'm actually going to be growing some cress seeds, and then I will be trying to conduct the extraction. So to do that first, what I'm going to be doing is I'm actually going to be growing them in agar. And to do that, I need 50 milliliters of agar, which I need 50 milliliters of distilled water. And then let's see here. I need 1.15 grams of agar powder. Now, while I'm doing this, I'm getting the water warmed up. And then what I'll do is I'll add the agar to the water. And agar is I believe it's pretty much it's made from seaweed, and it essentially it acts almost like jello. It's essentially a gel where nutrient that you can grow bacteria and plants in, and it's a for plants especially it's a good way to be able to grow things without in a more controlled environment, instead of having, for example, soil, which can have bacteria, which will affect your results, and just a different nutrient makeup. Here, you pretty much have a good control over things. You can also add different things to the agar to make depending on what you're growing in it. And the idea is to get this thing to a boil. And once you get it to a boil, it will clear up, and then I can transfer it to these centrifuge tubes. I'll fill them with 1.5 milliliters of agar. Put the seed after it solidifies. I'm going to put the seeds in, and then I will actually top them off and put them in a fridge for 24 hours. That way they can cool down, and the seeds can go through a cooling and warming cycle. And then I'll be putting them in the incubator under the grow light. Now, when I'm dealing with agar, I always like to use a larger flask than I need. I only have 50 milliliters, but this is about 150 milliliter flask. And the reason for that is because agar, once it starts to boil, it likes to essentially boil over. Where if I have a small flask and it boils over, you'll end up losing some of it. Where here it might get up to the neck, and then it essentially will stop boiling over once you take it off. And these are the seeds right here. They're cress seeds, Lepidium, Sativum seeds, cress seeds essentially. And I'll pretty much grow them till like about that much for 5 days, and then I'll see if I can extract some indole acetic acid from it. Which indole acetic acid is a hormone. It regulates the growth and the direction of growth of plants. For example, if the sun is on this side all the time, let's say on a window, indole acetic acid will actually break down with sunlight. So, and because this side is breaking down and it's a growth regulator, it increases growth, it'll cause growth in one side, and it'll point towards the sun. So now this is all done here. It's boiling now. What I'm doing, I'm putting 1.5 milliliters. And there is a slight time pressure when it comes to this stuff because it does solidify quite quickly. And once it starts to solidify, it's very hard to pipette it and move it around. Okay, so I'm almost done here. Now, once I get these in here, I have to let the agar cool a little because I can't. If I put the seeds in while it's still really hot, it could kill the seeds. It's always a good idea to make more agar than you need, just in case you, one, in case you spill some, and two, in case it starts to solidify and you start to lose some volume, because I can already see inside the pipette it's starting to solidify in there. And that's it for that step. Let me arrange these again. And the point of trying to detect the hormone that I'm looking for is I'd like to kind of do a follow-up to an experiment I did where I actually grew the same plants, the cress plants, with in a centrifuge, and then in the centrifuge it actually I had it at 2 G's of force of simulated gravity, and they grew about 15% less than smaller. Well, what I want to do is I want to actually be able to maybe do that test again and quantify how much the amount of this growth hormone that's in the plant, and see if that is a contributing factor to why it didn't grow as quickly as the control group of plants grew. Okay, they should be solidified enough. Now I got to put these seeds in here. Now in this experiment, I'm only doing 25 plants just to practice on. But when I did my original centrifuge experiment, so essentially I end up having essentially 200 of these, which can get quite tedious. And actually I'm going to do a little what do you call it? Assembly line here. Just drop them right in, one row at a time, and then I'll pop them in, because I have to push them a little bit down into the agar. But agar's it's used to grow bacteria. It's used to grow fungus. When you see somebody messing around with a petri dish and and you see that growth on there, usually they're growing it on agar. Usually, it does have the consistency of Jello, kind of like a hard Jello, except for it doesn't melt like Jello. Well, not that Jello really melts per se, but it definitely doesn't have it lasts longer than Jello. Like, it doesn't, like, this will be like this for like 5 days, 5, 6 days, 10 days. You can prepare an agar petri dish, and you can store those for a while, like weeks, months, until you need them. Which I'm pretty sure you can't do that with Jello. Come on, man. I can't get this one in. And last one. So now what I'll do is I'll actually place them in the refrigerator for 24 hours. And that'll cool them, put them through a cooling cycle, essentially. Come on. And then they'll warm up, and I'll put them in the incubator and then grow them for 5 days. So that's it for now, and I'll see you with my next lab activity.